Hello, lecture masaju wagdan I bolsai tao to hi energy ai ludiwitan masapena chu energy hi alhang pia hi kinetic energy to potential energy omji hin kinetic energy chu he da saw ne high school adon si sim kha de hintin chu biham kinetic energy chu see suppose you have a moving body, okay, a moving body or a moving particle so has some speed v, then the energy possessed by that moving particle is what we call kinetic energy. Hechuna hechu biham half mv square chula na formula chu hechi hi batang vector things are zinum vala chun hechi aji dan khachu. So kinetic energy can also be written as half m into, so here you can write this as v dot v, okay, v square pa hai na. So some fancy formula, okay. So we all know kinetic energy is half mv square, okay. Tempat revise na dan di question kan ga bol hen. So the mass of a cyclist together with a bike is 90. Cyclist khachu mi khachu cycle al hai na, a cycle to ama to pumpia away to 90 so let's calculate the increase in kinetic energy if the speed increases from 6 km per hour to 12 km per hour. But kilometer per hour hongke pi ala chun meter per second a convert dan pitam into 5 by 18 chula na chala hen. So that means you have 5 by 3 meter per second. Hichi biha pen hi initial speed chula na hi vi tiuta ala 6 km per hour apara 12 km per hour speed ki hial atila final speed chu so 12 into 5 divided by 18, 6 2 are 12, 6 3 are 18 to choose that ha. So to 5 are 10 by 3 meter per second. Okay, until kinetic initial kinetic energy chu k initial equals to, so half m to 90 chula na into, so 5 by 3 the whole square, so 5 by 3 into 5 by 3. Abana kia final result diham, so half into mass to 90 hiza 10 by 3 into 10 by 3. Okay. Question chun pido ham increase ati chula na, increase del chun final minus initial, the change ati na jo, change in kinetic energy. Ale increase to, let's say this is delta k, okay, delta kati phala chun always batang chemistry hi ta physics hi ta delta hong kati la chun chu change ti nai jana chu final minus initial hong te te so delta means k final minus k initial. Final result ham, so half into batang chi minus bol chun common so pp ha common, so half into 90 zong common na common inten abana so pp common am, so by 3 by 3 this would be 1 by 9 common chula na, final to 10 into 10, so minus initial to 5 into 5, so 9 10 2 5 hotel 5 into 10 10 are 100 minus 5 5 are 25, so that have 5 into 75, 5 5 are 25, 2 in hand 5 7 35 36 37 375 joules. Energy unit pa hi joules ong hindi cho. So you can remember unit of energy is joules. Work done as bolta chala na joules is ajo cho. Okay, so in simple formula cha na the kinetic energy to iti phalam tham the object khat chu if an object is moving with some speed, okay, then the kinetic energy is half mv square. Okay, atila bana chu potential energy bol masangwa na. So let's learn one very important theorem. So work energy theorem na za khadew na. So this one chipen hi class 11 na ko hum de za. Batang object khachu suppose an object is moving with constant velocity v, okay. So an object to constant velocity v chi cho atile hi v pa he na. So na change num wala na increase num ham decrease num ham na. So if you want to make some changes in this velocity, so what do you do? Pina bol dio ha. Tu hin force khat he na, perpendicular in apply leo chun hi force pa hen work done ima cha bol de ju lai object a he. Work done ju say tau chula na, work done ju ti phalam ding ham if a force is along the displacement, okay. So a force applied perpendicular will have no effect. So this will not change the velocity, okay. So velocity change nenti wala chun force khat chu chirang hai ne apply ngai cha, okay. So one force should be applied along the motion. So parallel component na work done bol ta cha atile. So here say a force is necessary to change the kinetic energy of a particle. Okay, so if the resultant force on the particle is perpendicular to velocity to perpendicular here achun, so the speed of the particle does not change and hence kinetic energy does not change. Okay, aji jo force khachu velocity to perpendicular ahuma malachun work done to 0. So work done imacham law na, so it does not affect the velocity. So kinetic energy changes if only the resultant force has a tangential component. Is like tangential kiti along the velocity ke sai ne so. Chila ka explain ta banga chuna. Okay, isi bang what force to along the velocity ya malachun velocity chu ki hial de na. So there will be change in the velocity. So let's say an object is moving with kinetic energy k equals to half mv squared yote. Half mv square hi object khachu chi cho atila chun force khachu along the velocity ke apply ala chun velocity chu ki hial na, so the velocity starts changing. So if there is a change, so let's say I'm going to differentiate this whole thing. Okay, so let's differentiate this formula with respect to time. Okay, atile so dk by dt aji jo velocity ki hiala la chun na, so here the variable is v. Okay, velocity ki hiala la chun kinetic energy on ki hial cho, so therefore I will have dk by dt. So this is equals to half into m mass to constant na. V square to differentiate bola chun 2v into dv by dt. Okay, ka differentiate ala na. Chila hi 2 cancel out. Remaining to pitam. So here I will have dv by dt hope ha. So dk by dt is equals to m into dv by dt. Okay, 지금 알아홈가 띵나. 제라히 vium dv by dt to acceleration atile 제라히 velocity. So dk by dt this is equals to ma into v. ma hi piha force chola na chi. Ale hi force pa cho hoilanga ke apply a tangential component ke apply cho along the velocity na. Atile si pa hi dikazit ya. So I have dk by dt is equals to force along the tangent. Okay, so into v. Chila hi bitang so fancy tiwa v dot v ka zita banga chu hila hi v dot v zila chun hila hi dot hum chu chila hi so m v dot v chila hi dot dena. So I will have here v dot v. So here I will have dot, here I will have dot, here I will have f dot v. As it's a force of velocity so niya chu vector so so I can write like this. Vector form is zila na, so I will have f dot v. Chila ko na so dk equals to f along the tangent dot v into dt. V into dt chu piha speed into time to displacement chula na, distance velocity into time to displacement. Okay, so I will have here dk equals to so force f dot x, force dot displacement chu pita work done chula na ipolo da chula last video. So here I can see that the change in kinetic energy, so dk means change in kinetic energy. Okay, so this is equals to the work done. Okay, I got one relation here. So like na conclusion ka bol chu piham tele. So the work done by particle. Okay, so the work done by particle, the work done on the particle by the resultant force is equals to the change in its kinetic energy. Okay, so this is what is called the work energy theorem. Now work energy theorem to piham, so the change in kinetic energy chipa he change in chipa he na dk pa he chipa he tang small d ma chun change tin hai. You can also write here so k final minus k initial. Okay, so this is work done. Change in kinetic energy is equals to the work done on the particle by whatever force you apply that. Okay, so that is called work energy theorem. So this is a very very important theorem. Okay, chalai chapter sunga dinga na. Theorem hijibo se umza ji work energy theorem pa hi. So most of the previous year's question observe le chun na. So they are based on work energy theorem. Okay. So remember the work done on the particle by the force, the resultant force, the applied force. Okay, so that is equals to the change in kinetic energy. Atila bana chu potential energy anulu tauted na. Potential energy masang chara chu you have to know two things. Okay, so two types of force. So conservative force to non-conservative force chu pi kisay na ha. Masapena definition chu na. If the work done by force, okay, if the work done by force does not depend on the path, okay, so does not depend on the path, then the force is a conservative force. So definition khat na, ilo definition dang khat chu piham tele. So here if the work done, okay, If the work done by a force in a round trip is 0, then that force is a conservative force. Okay, ita jong chuna sai theo na. Conservative force ang kiti phala chun it does not depend on the path taken. Alam piach ki depend only on the initial and the final position. Okay, so here it depends only on the initial and the final position. So that type of force is called the conservative force. So whose work done does not depend upon the path. Okay, whose work done depends on the initial only and the final position. Example to gravitational force involved na jijo phale spring force to chalai chapter involved Coulomb's force to class 12 electrostatics ako. Okay, so you have to remember 2 points. Ama sa pensu kasi nga so work done by force does not depend upon the path, then the force is a conservative force. Ahilawle work done by a conservative force during a round trip is 0. Okay, chicho point ni na. Atira non-conservative chu ipiham, so opposite of conservative. If the work done by force depends on the path, okay, so that is a non-conservative force, or work done by a non-conservative force during a round trip is non-zero. Okay, examples of friction force. Batang friction kun he chula surface so rafa hiya la chun na block khat chu chilai ko na ka slide cho left langa hi ka slide ala chun, so friction chu alumpia hi chula na alumpia friction chula. So here this is rough. Okay, so that means whatever work you do, whatever work is done by the friction, so it depends on this path here. Okay, chilai roughness pa hai na, so therefore friction is a non-conservative force. Okay, this is na potential energy masanga chu. Okay, between the conservative and non-conservative. Atira to hi potential energy chu huyaku na hong kon ham. Alhang pi hi mechanical energy, total energy hi kinetic energy to potential energy. So achum chuma na. Kinetic energy chu ti phalam ham when object is in motion. Okay, it has some velocity v, so that you have half mv square. Ale potential energy hi ti phalam ham. So here you see the work done by a conservative force is converted into potential energy. Ahilawle is stored. Is stored as so is stored as potential energy. Batang khunungzong la thermodynamics nan boldio na. First law of thermodynamics ko piha, energy can neither be created nor destroyed tichula. So when you do some work, there is some energy. So some work is done here. Okay, suppose let's say 100 joules. So this energy, this amount of work you do, work na bolsai palusunchi mangzing laucho. Okay, suppose that work is done by a conservative force. Suppose gravity, force of gravity hilole charge le charge ka ako force of attraction ham repulsion ham ji ako work done hungu male na. Chi work done pa chu interaction force of attraction hilole gravity chu kichai phala chu aman phala chun chi work done pa chu mangzing laucho. So that work done will be stored now as a potential energy. Okay, whatever work is done by conservative force will be stored as potential energy. Conclude ha. So that means potential energy is defined only for a conservative force. Okay. But then first line piha potential energy so huya kun ham. So when a conservative force does a work, okay, when a work is done by conservative force, then whatever work done is stored as potential energy. Atila chun potential energy kitipa hi conservative force box defines. Okay, so therefore you have see gravitational potential energy tizong na. So here example kapi hoy spring potential energy oma electrostatic potential energy cho. But we do not have friction potential energy. Okay, because friction is a non-conservative force, right? Okay, so here see another important point: the change in potential energy corresponding to a conservative force is equal to the negative work done by these forces. Suppose I have a force of gravity. Okay, an object is on the surface of the earth. It's an object in mass gravity. So this is a conservative force. Okay, suppose you want to lift this. Okay, you want to lift this. So when you lift, so this object goes upward. Okay. Conservative force pa sunui lang ma ivan displacement sa chung lang na. So your displacement is opposite to the force. That means the work done is going to be negative. Okay. Right. So remember see, mathematically I have written here, okay, so the change in potential energy is equals to the negative work done. Na melchi diu chu bhem dila formula kaji pa hai. So this formula you have to remember. Okay. Asi jo potential energy derivation zo sia kho chevina mandiu cho. Potential energy ki umna zo sia khona. Gravitation chapter azong na mandiu, spring potential energy derivation azong na mandiu abala class 12 electrostatic potential energy azong khona. So azong khona mandiu. Okay, so remember this is a very important relation. So U initial minus U final should be equals to work done by conservative force. Okay, example khali jong bolu chu. So here, one more thing here. Relation between force and potential energy. So first, let's do one question on this one, and then I will explain this one. Okay. Question 2, you can be asked many type of question. Okay, for example, U initial minus U final equals to work done by conservative force. Work done should be force into displacement. Na? F dot dr if the force is constant. Suppose I have a graph here. Graph question lang gadong tayo sulahin. Graph to PKPM. So here let's say a force versus displacement graph is given. Okay. So object starts from here. Okay, it goes here and then comes down. A, B, and C. Okay. Let's say R here is a so let's say this is 8 and this is 10. F2, let's say this is 50 joules. Not joules, Newton. 10 Newton force. Okay, ako the question so if potential energy, okay, PE at A is equals to is that so let's say 100 joules. Okay, PE at A is 100 joules. Then find PE potential energy at B and C. Okay, B and C. This is the question. So graph kat ong na force versus displacement graph ke pia chalai chu given chu pia pat na chuna potential energy at A chu zat ham 100 joule ke pin ten B to C chu zat ding ham. Okay, so that is the question. Atila chalai na bol yo betang he graph basic maths graph azong ka explain itan about like kinematics azong graph question tam tai solve ta so he chala he see whenever you have actually this formula. So this formula is integral. In general, it is integral f dot dr. Okay. Chilahi integral hung part phala hinchi force versus displacement graph area under curve kiti cho. So the meaning of integration means area. Area tini cho. Atila hi area hu. So U A chu potential energy A chu 100 joules. Okay. So what is UB? We don't know. Okay. Formula so if I apply this formula here, so U initial, that means UA minus UB should be equals to, so work done from A to B. Okay, work done from A to B. A to B sunga work done is at in F versus R graph, work done is the area under the curve. Chila area pa in hold you. Okay, is that the so here I have this is a rectangle na, so 10 into 8 is a work done. Chilai area pa hai na. So see question must happen. So B whole nothing also you have to use A and B here. Okay. So UA minus UB. U initial minus U final equals to work done by conservative force. So the work done is the area in FR graphs. So that means from A to B. So the work done is this area. Okay. So this is 10 into this is 8. Solve the result of them. UA to 100 kPa. So minus UB should be equals to 80. Sila ko na 100 minus 80 should be equals to UB. Na UB to zarang podam UB to 20 joules. Okay. Alright. Abana chu C whole nothing achu pinabok ke ha. So now from UB to UC. So UB minus UC equals to again area under the curve between B and C. B apat C ka chilsun chalai no area pa he triangle ka kanai chula na triangle. Okay. So what is the area of triangle? Half base into height. So half base to 8 to 10 kika achu 2. Okay. So y axis lang achu 10. So UB to that ham 20 from previous question. So UC. So this is 10. Okay, so from here, what is UC? So 20 minus 10 is equals to UC. So or UC is equals to 10 joule. Okay. Hi formula ki apply na graph question khan iga bolo cho chalai theory azong so numerical questions jong ki sim thaina he jong le formula apply dan pa chu. So this is important. Okay, so U initial minus U final equals to work done by conservative force. Atile bana hi chalai anuya relation between force and potential energy pa hai na. Chi veleu chun hi cho hai na mu kha lo mai thiwe za class 11 simple lai ho hi mai thina. So some of you, it may be the first time you see this one. HAT ki pola ek sayam tela force pa hai na. So force is equals to dou U by dou X I cap plus dou U by dou Y Z cap dou U by dou Z K cap. Okay. HAP tiram tela chipen hi partial differentiation ki to chim yan cha na. So this is partial differentiation. Butang partial differentiation jo pitina ham tela suppose function khan jo na chala hi. Suppose you're given a function U is equals to some new function. Okay, y thing y equals to so x cube y z squared yute. Okay, atila chala hi. So if question depend hi let's say pila de ha u tu na chala hi u ka tu ha u to x cube y z squared ke pi cho atila chala hi dou u by dou x cho pi de na ha. Dou u by dou x nan di phala chun he chala hi x pa he variable cho adang zo si ju constant na hela y to z teni hi chiteni hi ania constant cho. So only x is a variable. Okay, atila ka difference na la chun x cube differentiation chu 3x square hong ding y to z cho angai ngai ta jun koi tiu. Okay, so you differentiate only x and leave y z as it is. Ala chala hi dou u by dou y chu be ha. Dou u by dou y ka tiala chun y pa he variable hong ding x to z pa chu constant hong de. Na katile x cube x to constant na y differentiation to 1 so z square. Okay, that is dou u by dou y. Ale dou u by dou z chu pe ha. Chila example akoila wala chun so x cube jong chu constant y jong chu constant z square chu variable na atila z square differentiation to 2 into z. Okay, so that is the differentiation. Chila partial differentiation ki bolan chuna jepen here class 12 maths part 12 maths na. So there I think you have calculus, so there you will do these things. Okay, so force is equals to dou u by dou x I cap dou u by dou y z cap dou u by dou z k cap. Okay, so partial differentiation of potential energy will give you the force. So phala question previous question involved. Okay, so now let's do one question this here. It's a partial differentiation formula penjana. Example given potential energy chuna as a function of x, y, z. Potential energy function ke pi cho suppose it is given that you have so 3x square I cap plus say y cube z cap plus 2k k cap tivte hechi potential energy ke pi na atel question to find force. Okay, force at x equals to position at position ka pi the 1, 2, 3. Okay, 1, 2, 3 force hold body. Okay, so then see a relation pass of force is equals to so dou u by dou x I cap. Okay, plus dou u by dou y z cap plus dou u by dou z k cap. Okay, partial differentiation bola jana chala hai. So therefore the force is equals to must apena chu chala whole function pa hai na u pa hi. So with respect to x differentiate bola chun hi chalanga hi y to hin z hi constant chula na. Constant differentiation chu it will be 0. Okay, so therefore you will be left with only so 3x square. Na betang so dou u chu chi hi za by dou x. Okay, So if I split this into 3 terms, so here I will have dou by dou x into these things. So dou plus dou by dou x into these things plus so dou by dou x into so these things. So this will be 0. Okay. So this will be 0. As you try term then x lo chula. X na so first term pa boss na. So here I will have masapena dou u by dou x ahi. So I will have here so 3 2 are 6x I kept differentiate bola chun na. So plus dou u by dou y ka bola chun chito hinchi 0. Okay. So remaining is this one. To choose that y cube differentiation 3 into y square z cap. Okay. Plus abana so dou y dou u by dou z pa ho chite ni constant na. So the differentiate value chun 0 with respect to z and differentiate ball value chun 0. Okay. So this one you take as z na x y z laute. So here that means 2z ka differentiate ala chun 2 remaining na. So 2k. Okay. So this is your force. Atila at x is at position hui pi ha. Position aho 1, 2, 3 kiti chula na. Atila at 1, 2, 3. Chila hi pe x value hi 1 hitting, y value chu 2 hitting, z value chu 3. Put leo chun force is equals to 6 into 1 to 6 I cap plus 3 into 2 square na. 2 are 4, 4 3 are 12. 12 z cap plus 2k cap. So this is the force. Okay. Hechi example ni bolna ji hui pham tila chi hechi big formula pa hai na chala hechi formula pa hai amandan ka ga besa go cha. So I'm just showing you how to use this formula. So you'll be given a function, potential energy function here. Okay. So they will ask you force. So then you have to partially differentiate this one. Okay. X pa so choma differentiate the value, cha pa so jiung poding, y pa so choma differentiate the value wala jing poding, z pa so choma differentiate the value wala chun jiung poding. Okay. So before we solve questions, I would like to summarize work energy theorem supita. So the work done on particle is equals to the change in kinetic energy. Okay, depends on work energy theorem taisa. Ani na pa chapiham work done on a system by all the forces. Okay, all the forces that is external plus internal. Okay, so that will be equals to the change in kinetic energy. Okay, so work done on the system by all the forces, external plus internal, is equals to the change in kinetic energy. A force is a conservative if the work done by it during a round trip is always 0. And it will be non-conservative if the work done by it by the force during a round trip is not 0. Okay, as I explained here. So the change in potential energy corresponds to the corresponding to conservative internal forces is the negative work done by as I ball pen so u I minus u F equals to work done by conservative force na. But if you want to modify, you can modify as out WC kati pa na Japan here. So there is the work done by conservative force. Okay. So a force is conservative if the work done the change in potential energy of a system with the corresponding to conservative internal forces. So this is equals to the negative work done by these forces. Okay. If no external forces x. Okay. The conservation of energy video in volume. Full video in volume. If no external forces x, external force so all the internal forces are conservative. Okay, so then the mechanical energy of the system remains constant. Mechanical energy to conserve the so initial energy equals to final total energy in volume. So this is a concept of conservation of mechanical energy. Okay, so this one we'll do in a separate video. July video point so this thing you remember. Okay, let's solve some questions. So first question. Which of the following forces cannot be expressed in terms of potential energy? Here Z means 2025 question. Option hola hai na. Option hola hai which pen here potential energy ke expressed hello ham. But then kasi so potential energy chukuya ha. So it is due to conservative forces. Okay, if the force is not conservative, so then you will not have energy. So therefore friction force. Na Coulomb's force to Coulomb's force to restoring force to spring force na to gravitational force hi is conservative chale na conservative hi chu chipa hi. So therefore this is the answer. Okay. Abana azawa point li kan pi hoju na point li nga summary kan pi hoju. So the negative work done by conservative force on the system equals to the change in potential energy. Now, U initial minus U final equals to work done by conservative force, or so U final minus U initial equals to negative work done by conservative force. The work done by external forces on the system equals to, so this is kinetic energy. Work energy theorem pass na. Abanasu thumna pen 2C. So the work done by all the forces external, internal. So this is equals to change in kinetic energy. As I say pen na. So here you see external and internal is equals to change in kinetic energy. Okay, so this is the answer for the third one. Right. Next question. So C, chalai ka sajo kasi paso na U hungi pidaso chalai. So U is given. So U is equals to 2x square plus 3y cube plus 2z. Okay. Potential energy function jo kipi question pi do ham. So find the magnitude of x component both also chalai force acting on the particle at 1, 2, 3. So question is solved kilau di chalai na. So here if you apply force to potential energy relation to dou u by dou x I cap plus dou u by dou y z cap plus dou u by dou z k cap. Okay. Atile chunga pa ho with respect to x differential y to z who constant na. So due to the second terms, so if you differentiate this with respect to x, this is 0. So this is 0. So differentiation of 2x square is what? So 2 are 4x I cap. Okay. Plus Abanachu with respect to y differential 3 are 9 y square plus with respect to z is 2. Okay, so this is the force z cap plus 2 k cap. Atile point so hilai at point P 1, 2, 3 x to y x y z helon chivele poleuchun. So force is equals to 4 into 1 is 4 I cap plus 9 into 4 to 36 z cap plus 2k cap. Okay. So like question jo bido ham question chun x component and na. So question is asking x component. So this is the x component. So answer is 4. Okay. So this is JEE Mains 2025 question. Abanachu. So next you have another JEE question. Identify the correct statement. So this one I don't think is 2025. Okay. So this make a correction. I think this is 2022 or 23. Work done by a man in lifting a bucket out of well by means of a rope tied to a well apan ako bucket time cho bucket na si chalai ko na hi khawa ki khai tau cho khawa ka indin puli lai na mi pain chalai pan akai cho. So the man is pulling. Okay, atile mi pason akai to wala chun force I apply chula na malanga khui. So the man is applying force on this side. So what is this force basically? It's a force pa he piha. It's a force pa he tension force. So this is the tension force. Mi pan force applies as a so tension hising that. Okay, so that means here you will have work done by tension. Kailo chun bucket pa he chung he chito. So the displacement will be this. Okay. So if you see, so the force is also upward, the displacement is also upward. So they are in the same direction. So the work done will be positive. Okay. Atila first step mention pido ha. So work done by man lifting so this is negative ati na. So that means this is wrong. Okay. Ajijo force to direction to same direction ati ala na. So if the force is acting along the same direction as displacement, so the work done is positive. Okay. Adina piha work done by gravitational force in lifting the bucket. Atila to hivela chun gravitational force hoilangam ha. So downwards na. So that means mg. Okay. So this is the force of gravity. So work done due to force of gravity. Force of gravity is downward is a bucket so you see the displacement and the force are opposite direction. Okay. So that means the work done will be negative. So this is correct. Okay, B is correct. So work done by friction on the body sliding down an inclined plane is positive. Question. Suppose I have an inclined plane like this. Here rough surface. Okay, this is a rough. Atila chila he block at so slide down so. Okay, slide down on friction so ha. So friction is opposed. Okay, so this is friction force, right? And the motion, the displacement is where? Displacement is towards downwards. Block cho chi solution displacement cho chilang is a friction force cho chilang is na. So the friction force and the displacement are opposite direction. Chi also work done to negative hingai cho. So here it is written positive, so this is wrong. Okay. I'll just use a different color. Cross. Work done by applied force on a moving body on a rough horizontal plane with velocity is always 0. Suppose a body horizontal surface a body khatuma it's a force khatin up kai chona chalahin. So work done by applied force on a moving body on a rough. So surface is rough here. Okay, so this is rough. So rough. So that means you'll have friction where friction should be opposite to motion. Okay. Atile question pido ham a uniform velocity chijulana force to constant lesson. So here you'll have a uniform velocity v. Okay. So work done by applied force on a body moving on a rough horizontal plane with uniform velocity is 0. Work done to 0 ahead teacher. Okay, if the block is moving, okay, if the block is moving, so there is a displacement. Okay, so some work has to be there. Kinetic energy zone. Okay, so here work done equals to 0 is wrong. About the last pen could be so work done by air resistance on a oscillating pendulum is negative. Pendulum here. Suppose I'll just give you here. So I have a pendulum here. Hichipa he release ball length. So it will go downwards. Okay. Air resistance should be so it is like a friction. Okay. So air resistance on this bob will be on the other side. So this is air resistance. Friction force due to air. Okay. Motion to left lang is a friction force to lang it is negative. So this is also correct. Okay. So answer is B and E only. Okay, force kipia. Assuming distance meter, force is Newton. A particle moved from 1, 2 to 2, 3. So then the kinetic energy change in kinetic energy do na. Then work energy theorem chupita. Work energy theorem chu. So change in kinetic energy, right? So that means decay. So this is equals to what? Work done. Work done. Work done I can write here F dot dr. Okay, so I can simply find the work done here. So that will give you that change in kinetic energy. Okay, force go 4x I cap plus 3y square z cap. G force na. So dot dr ho pita dr ho dx I cap plus dy z cap taki jithai chola na si. So dx I cap plus dy z cap. Okay, take the dot product I z z. So I have 4x dx plus so 3y square into dy. X ko ya para hela chan ham 1 apala 2 chan na x component pa 1 apala 2 chan chichu x cha. So 1 2 2 abana y pa kola from 2 to 3. Okay, so 2 to 3. Chi integration ga solve leo chun na. So force 4 into x integration so piha x square by 2. Right, so this is from 1 to 2. So plus 3 into y square integration to y cube by 3. Okay, y cube by 3. So this is from 2 to 3. Limit put leo chun achunga ho 2 into 2 chun po 2 square to 4 minus 1 square to 1 plus 3 cube to 27 minus 2 cube to 8. Okay. 2 into 3 to 6 is a plus that 27 minus 16 ho. 19 din na sila ko 19. Okay. So 6 plus 19 to 25 joules. Okay. So this is the change in kinetic energy. Question answer to be 25C. Okay, next question, medical exam question. 2025. So this is also another question on work energy theorem. Okay. Kinetic energy of two cars keep Ka the kinetic energy of car A to Ka to 100 joule keep na ji. Kinetic energy of B to 225 joule keep in. On applying brakes, car A and stops after 1000 and car B stops. Batang brake ang ki apply ala jun car A to B chu hunki stop beta chuna. So if they stop, then what is the final kinetic energy? So Ka initial, Kb initial tete. Ka final chu za ding ham 0. Aji chu kinga ta chula. So Kb final zong chu. So this is also 0. Okay. Distance could be na displacement chu. Displacement of A chu za ham 1000 meter. B chu za ham B chu 1500 meter. Okay. If FA and FB are forces applied, so FA chu force applied on A, FB chu force applied on B. Atile force ten ratio passes at them. Butang dk equals to K final minus K initial equals to work done force into displacement. Chipi ha chipen hi work energy theorem cha chipen hi. Hechi mangleo chun A na hu K final is 0 na minus K initial to 100. So this is equals to force into displacement. So FA into 1000 displacement. So na chi equation 1. Awana B azong hu kibang. So 0 minus 225. So this is equals to force on B, okay, into 1500. So this is equation 2. Okay. Atile FA to FB who equation 1 to 2 divide boleh chunzan pot ha. So if I divide 1 and 2, I will have here 100 minus 100 divided by minus 225. So this is equals to FA into 1000 divided by FB into 1500 na. Cancel the cancel chunzan di ha chela hi. So chunga hi 5 to 10 5 4 are 20 5 5 are 25. So 5 4 are 20, 5 9 are 45. Minus minus cancel out. Zilanga kholale 0 0 0 0 5 2 are 10, 5 3 are 15. Na abana chu left right hand side or left hand side ho 2 1 is 2, 2 2 are 4, 3 1 is 3, 3 3 are 9. Atila finally is that so 2 by 3 is equals to FA divided by FB. Okay. So the ratio is how much? 2 by 3. Okay. Option D. Last question. Okay. Medical exam question mama na 2025. Object is moving along horizontal x direction while kinetic energy 10 joule is displaced through displacement kpa force on kpa na. Atile initial kinetic energy to 10 joules kp cho Japan hi initial kinetic energy is a final kinetic energy to pm. So that is the question. Okay. So just simply apply work energy theorem here. So K final minus K initial equals to work done to force into displacement vector ahong kp alasun F dot x. Okay, if the force is constant, but work done involved na work done to constant force azong variable force azong involved out. Variable force ahong hilachun integral F dx na ilole dr constant force hilachun F dot r hilole F dot x involved na. So from here, they ask you kinetic, final kinetic energy, initial to 10 joules. So this is equals to, so force to minus 2i cap plus 3j cap. So dot displacement could be 3i cap plus 0j cap. J cap on opposite. So you can put 0 here now. So k final minus 10 is equals to dot product city ball data. So like times multiply minus 2 into 3 to minus 6 is plus 3 into 0 to 0. Okay, so from here, K final equals to 10 10 minus 6. So this is 4 joules. Okay, so answer is 4 joule. Okay, that much question. Previous question is solved now. Basic question is solved now. It's answer. It's a video here. Kinetic energy to potential energy basic. Then work energy theorem to ibol hoja. To hi potential energy tempo detail line bol ngayon na. As it's potential energy to PP gravitation homa spring potential energy spring zongi bol na ilaw spring force the also loss of motion na bol thai zai zong le hilai bol jing thau ji wa na. So we're going to do those things. So potential energy we will do in the next video, and next video we will do conservation of energy. Okay. Atila video ding ahi. So we'll end up here. I hope you understand. Thank you for watching.